Okay. So. All right, folks. So I'll wait. Okay, we need to be listening here. All right, it's not easy stuff. Okay, so let's listen up. All right. So the notes, right? So what we're talking about today is simplifying rational expressions. Okay. So what you didn't realize, right, is that's what we were kind of doing already. So for example, okay, a rational expression. Okay, a rational expression. So, rational. That word rational, okay, that's also the same word used to describe, in math, used to describe numbers that can be written as what? Does anyone know? As what? A ratio, yeah, or a fraction, right? Exactly right. Yeah, that's the idea, okay? So a rational expression. That's really good. I never thought of it that way. Alex, you taught me something today, okay? Yeah. So a rational expression is something that can be written as a ratio, okay, or as a fraction, right? So, for example, 3/4 is a rational number, okay? The number pi, okay, pi is irrational. You can't write pi as a fraction of two numbers, okay? Pi is a non-repeating decimal that goes on forever, and so that's why it's not a rational number. It's an irrational number. So a rational expression, okay, is a fraction, okay, or ratio, okay, of two polynomials. Okay. Okay. And so we work with these. So for example, if we wanted to simplify, as an example here, so our directions are to simplify. If we wanted to simplify, for example, 35n over 35n squared. Okay. So again, is this a rational expression? Yes. Okay. It's a fraction of two polynomials. Okay. Here's this top polynomial is actually a monomial. It's really one term. It's one product. Okay, divided by another polynomial, okay, another product there, 35n squared. Okay. All right. So, do we know how to simplify this? Yeah. Okay, so someone will raise your hand and tell me, how might we go about simplifying this? How might we go about simplifying this? So, let's go to Jordan. Jordan, we haven't talked to you, okay? So
1n over 1n squared.
Okay, so the 35s, Jordan wants to cancel out. He sees 35 divided by 35. Those both divide out to just 1, and so he says that leaves us with n over n squared. Okay, right? 35s cancel. They're gone. N over n squared. Can we simplify it any further? All right, okay, so yeah, so what we can write n as n to the what? N to the 1, right? Yeah, you're going ahead of me, Debbie, so yeah. But that's right, n to the 1. And then, right, if we have n to the 1 divided by n to the 2, right, it's the same base. What can we do with the exponents? We subtract. Yeah, they're going to cancel out, and so we're left with n. What's 1 minus 2? Negative 1, okay. So there it is, n to the negative 1, which again, we shouldn't leave things as negative exponents. So instead of n to the negative 1, we'll rewrite that as what?
1 over n.
1 over n. Or 1 over n to the 1 if you want. That's fine too. And there's our final answer. Okay? So, new name, same technique, right? This is exactly like we could have seen this problem on our homework, no problem, right? We could have seen that. I mean, that kind of looks like maybe, like this one right here on our homework, or maybe more like this one on our homework. Okay, right? But that's something we've seen before. No problem, right? No problem. All right, let's try another one. Just to make sure we're still good with this. So let's say 45x squared over 25x. Okay, 45x squared over 25x. Again, we just want to simplify this. Okay, we just want to simplify. So we want to cancel out anything we can here with division. All right, so let's go to Addie. Addie's like, man. All right. Can you see it okay, Addie?
Yeah.
Okay, so 45 and 25. Do those divide evenly? Yeah, no, but can they simplify? Okay, so we don't want to subtract those, but we're dividing those. So 45 divided by 25, we don't subtract, we divide. Okay, yeah, there you go. They both divide by 5. So if I divide this top one by 5, what's 45 divided by 5? 9. 25 divided by 5? 5. Okay, so we divide both those by 5, we get 9/5. Okay, now, Addie, can we simplify those any further? Yeah, 9 and 5, they don't have any more common factors. Okay, good. So we'll rewrite 9/5 here, 9 over 5. Okay, and then x squared divided by x. This is x to the what, by the way, Addie? 1. And so x squared divided by x to the 1, what's it going to leave us with? X to the 1. That's right. I'm going to put that out here to the side. X to the 1. Okay.
You could also write 9x divided by 5.
Right. So Jordan said we could also, if we wanted to, since this is x to the 1, it can go up in the numerator here, and we can rewrite that as 9x over 5 like that. So either this answer or this answer here is fine. Okay?
Okay.
Questions on any of those? Nope. All right. Very good. Let's take a look at another.
You always want to simplify the numbers, right? Like if they don't divide.
Correct. You want to see if, yes, you want to see if the fraction simplifies. It might not divide evenly. Like, so here, 35 divided by 35 divides evenly, even cancels out, right? Here, 45 and 25, Addie was able to say, right, they did not divide evenly, right? I can't do 45 divided by 25, but it simplifies to 9/5, and that's good. Remember, folks, if you have a graphing calculator, right, it's real easy to simplify that fraction. 45, you just type it in, 45 divided by 25, and hit math, enter, enter, and that gives you the 9/5. Okay, so that's an easy way to simplify it. Okay, another one. Okay, so now, let me point out some things here. What we cannot do here, we cannot just cancel the x with the x here, or the x with the x here. Okay, or the 8 with the 72. All right, those do not cancel like we think, because we have this subtraction here, and because we have addition here, and a subtraction here. All right. Remember, up here we were able to cancel things out no problem, but what's the operation between the 35 and the n? Is that add, subtract, multiply, or divide? Multiply. And what about down here in the denominator? It's all multiply. And what about here? All multiply. And down here, all multiplication. When we throw in subtraction and addition and subtraction there, okay, we know these things are now kind of separated from each other. We can't just like break it up and say, x divided by x squared, that cancels out, and x divided by x. No, because it's not a product anymore. We have subtraction and addition in there. So, how do we go about simplifying this? Well, we can actually make a product here in the denominator.
I think I know how to do it.
Okay, so let's take a look at this. So I'm going to leave the numerator alone. All right. How can we work with this x squared plus x minus 72? Alex, you have an idea?
Can you just add, can we add the f to the x squared?
Oh, like a 3x squared or something like that, or 3x cubed. So, good question. What do you guys think about that? Can we add x squared together with the x?
No.
Why not? Because I said it like that? No.
Yeah.
But they're not like terms, right? Why aren't they like terms here, Alex? Right, this one does not have a square, so we can't put them together. Good thinking, but we can't do that. All right, Debbie, idea? Okay, x squared plus x minus 72, folks. Remember, we've seen problems like this before, right? Way back last unit a couple days ago, right? We talked about how to factor these. And in fact, when we want to factor this, in this case, we're looking for two numbers that multiply to make what?
72.
A negative 72, right? And add to make what?
1.
1, right? Because there's a 1 in front of the x there. Okay, so can someone think of two numbers that multiply to make negative 72, but add to make 1? Let's go. I'm going to go to Eli, and then we'll check with you, Alex. Yeah, what do you say, Eli?
I'm not sure which one is the The 8 and 9.
Okay, so 8 and 9. Alex, can you do, is that what you're going to say, Alex, 8 and 9?
Another one.
Yes? So, which one is which, though? Do we want to put,
Why don't you just be like negative and both of them negative?
we want both to be negative? Well, if both are negative, so if I do negative 8, it'd be positive 72.
X minus 8 and X plus 9.
X minus 8, X plus 9. Exactly right, Tristan. Very good. Okay? Now, so we, again, x squared plus 1x minus 72, that's a polynomial, that's a quadratic, right? We can factor it to x minus 8 times x plus 9. Now, does anyone see anything significant in those two factors? Yeah, we have x minus 8, right? It's the exact same thing that we have up here. So this x minus 8 is an entire quantity, and this x minus 8 is an entire quantity. And now it's a product, right? It's x minus 8, the quantity, times x plus 9. So what can these x minus 8s do? They cancel. But well, combined by canceling. That's exactly it, though. They cancel. Okay? So, thank you. Okay, they cancel. Yeah, you can sit right there next to Jordan if you like there. Okay? The x minus 8s cancel, which leaves us with what in the numerator? A 1. And what is left in the denominator? X plus, careful, not x plus 8, x plus 9. Yeah, x plus 9. Okay? And that's our final answer. Okay? You see that? Simplifies. So we started with some crazy polynomial, and now we have a slightly more simplified polynomial. Okay? All right, let's try another one. Excuse me. All right, we're going to do x squared minus 3x minus 54 all over x minus 9. X squared minus 3x minus 54 all over x, excuse me, minus 9. All right. So again, if we look at this, I see another quadratic. Now the quadratic's in the numerator, and I see a factor x minus 9 in the denominator. So let's see if we can factor this numerator here and maybe get something to cancel out like we did here in this previous one. All right. So let's go to someone I haven't heard from yet. Let's go to Mitchell. So Mitchell, can you factor that numerator for us? Two numbers that multiply to make negative 54 but add to make negative 3.
Negative 9 and positive 6.
Okay, so yeah, x minus 9, x plus 6 is how that numerator factors. And then we have an x minus 9 in the denominator. Okay, so you see how we're kind of bringing together these two topics, right? We talked about factoring a unit ago, and now we're talking about dividing. And so, Mitch, what can we do from here?
Cross out the x minus 9.
Yeah, the x minus 9s are in common there. We can cancel those out. Again, here we have a product of two things, so the x minus 9s cancel.
I have a question for this one. Could it be like x plus 6 over 1?
Yes.
Can it be that way?
Yes. So answering that question is, can we write it this way? Yes. Or we could just write x plus 6, right? Anything over 1 is just itself, so either one of these answers is fine. Okay. Can I write this as just x plus 9?
No.
No. Yeah, it's in the denominator, right? 1 over x plus 9 is not the same thing as x plus 9 over 1. But here, x plus 6 over 1, remember, what does it mean to be over 1? It means to divide by 1. But if you divide anything by 1, it's just itself, right? Anything divided by 1 is itself. So it's like, no comments. No surprise there. All right. Let's try one more like this. And actually, I'm going to have you guys try this. So here we go. A plus 7 over a squared plus 6a minus 7. Yep, sorry about that. A plus 7 over a squared plus 6a minus 7. Y'all go ahead and give that a try, okay? Take 1 minute. Give it a try. And then we have one more kind of type that I want to look at here after these. I just want to see if you guys can get this one. So again, a plus 7 over a squared plus 6a minus 7.
Give this one a shot. Yes. Yes, very good. Good job, Max. Well done. Wait for it. We got work to do. Good. Good job. Try this one, okay? Then you put your head down. What are you doing? Triangle minus 1. Are you ready for me? Oh. Classic way, right?
No, it's not. No, it's not. Stop lying. Yes, you are. That's not.
Well, this one, yeah. And so, I can't read that much. Other teachers didn't care, so just be on your toes.
That's why I want you to have that.
Okay.
Okay, let's see how we did here.
I got C.
Oh, she's not here. Alright, Alex! Por favor, would you please tell us, how does this factor?
It would just be, 1 over X.
Sorry, what is the denominator factor to be first, before we get to the final answer, sorry.
Okay, it's just, 8 plus 7.
Yeah.
And then 8 minus 1.
Yeah, very good. Okay, so then, right, once we factor that denominator, Alex, we see a product of two things right here, and this exact quantity, 8 plus 7, is what we have in our numerator, so what can we do? Make them cancel. And so what's left in the numerator? 1. And then denominator?
8 minus 1.
Very good. That's our final answer. Shh, that's it? That is it? Okay. All right. What about... Okay, what about simplifying this fraction? All right.
It would be the 60 over 32B.
So we can break it up, but I'm not going to have us break it up here. I'm going to have us keep it together. So, first of all, are either of these two things quadratics that we can factor, like using our product sum kind of thing? Yeah, no. But if you look at the numerator here, right, and the denominator, okay? The numerator, we have a way, we can still factor this numerator, right? We can factor out a GCF, right? 56 and 72 have a common factor of what? What can we divide 56 and 72 by? 8, yeah. So we factor an 8 out of this, okay? And parentheses then, 56 divided by 8 is what? 7, and there's a V there, so 7V, minus, what's 72 divided by 8? 9, all over, okay, 32V. Go ahead.
Can I say, would you also simplify this?
Yes, so exactly right. So now, because we have this 8 that's outside the parentheses, right, it's in a product with the 7V minus 9, the 8 and the 32, we can simplify those. Okay? We could not just straight up simplify the 56 and the 32. Again, we have subtraction there between these two quantities. But now that we have 8 times the quantity 7V minus 9, we can now simplify that with the 32, right? Just like before up here, right, we can't simplify the a and the a squared because there's addition between them. But once we factored a plus 7 so that it was multiplied with a minus 1, we can cross out that whole quantity there. Same thing here. The 32 and the 56, there's still some more stuff here with the minus 72, but because we made it a product with the 8, because we made it a product with the 8, okay, this 8 and the 32 now we can simplify. We can cross that out there. Okay. So, what do 8 and 32 simplify to be?
1/4.
So yeah, the 8 divides out, and the 32 divides by 8 to make 4. 1/4, that's right, okay? And so in the numerator, all that we're left with is 7v minus 9 over 4v. Okay? Now notice, this v cannot cancel out in the denominator here. It can't cancel out because this term has a v, but this term does not, and so we cannot cancel that v out. This is the best we can do. 7v minus 9 over 4v, and that's it. Okay? The v cannot cancel out. These v's cannot cancel out because both terms don't have a v. Okay? So we can't cancel it out. All right? Let's look at another one. Let's look at another one here. Okay, let's try another one. Let's try 5y squared minus 5y all over y minus 1. Okay? 5y squared minus 5y all over y minus 1. Okay. Now, we can't really do anything here in the denominator, right? But we do have this numerator, and what can we do with the numerator?
Where's the
We can factor out what?
5.
A 5y, right. So again, this is not a quadratic, right? I mean, it's kind of like a quadratic. It's got the y squared, it's got the minus 5y, but it's missing a number out here, right? But we can factor a GCF out, right? A greatest common factor, right? They both divide by 5y. And so let's rewrite that here. If I write a 5y here with parentheses, okay, what's going to be in the parentheses here? Yeah, if I divide a 5y out from 5y squared, it's going to be y, right? We're left with a y.
Minus 1.
And then if I divide a 5y from 5y, you're left with minus 1, right? It's just minus 1. Over
They cancel out.
y minus 1. Right? Is everyone following that? Okay.
And then they cancel out because of the...
Alex, no? You see it? You see it? This, we can factor GCF out here, 5y, leaving y minus 1. Why is that helpful? Because, yeah, now we have y minus 1s that can cancel. And we're left with just 5y over 1 if you want to leave it that way, or you can write it just 5y. Okay? Pretty crazy stuff, right? Pretty crazy. All right. Let me show you one more, and then I'll get you guys started on your assignment. Okay, last one here. So we're going to say 3x minus 6 over 3x squared plus 12x minus 36. Okay, so let's kind of consider this one right here. Corey, head up, buddy. This is the last one you need to see, and then, we'll get started on your assignment, all right? So hang on a second, Jordan. I want to ask a question, but then we'll go to you, okay? So if we look here, all right, we have 3x minus 6. Now, does anyone see something we can do to factor this? What can we factor out here? We could factor out a 3, okay? So that's helpful. So we'll keep that in mind. And the denominator. Can we factor a 3 out of here? Yeah. Well, this is also a quadratic, though. So we could also try and factor this using like slide and divide. Okay, or kind of guess and check method, but I think slide and divide is probably the better way. But notice that all these numbers here divide by what? 3. So let's factor a 3 out first of the numerator and denominator. So the numerator will be 3 times x minus 2. Excuse me. The denominator will be 3 times x squared plus 4x, right? Because 12, if you factor 3 out of 12, it's 4. And factor 3 out of 36, it's negative 12, because it's negative 36. Okay.
Why would you, without, why would you change it to, like,
Right here, because when we factor the 3 out of this numerator, 3x divided by 3 is just x, right? 6 divided by 3 is 2. So that's where you get the 2 from. We're dividing, right? When you factor out, you're dividing.
did we just go up with the bottom? Okay.
Nope, we can do it wherever we need to do it. Wherever we can do it, we can use that to help us.
Say we didn't, like, first top and just left it at 3x minus 6.
If you left it, okay?
And then we just did the, like,
And you factor the 3 out of here?
yeah, was that mess us up?
Potentially, yes, because then you'd still want to factor the 3 out of the numerator if you can. You're looking at, I would say, first thing you want to do is factor out a GCF. See if you can factor a GCF out of the numerator denominator, okay? And then go from there kind of thing. Okay, and then see if you have a quadratic here now, Alex. But what can we do with the 3's?
You can
They cancel, right? They're gone.
Goodbye.
Goodbye. Now, the numerator is still x minus 2, but we can do one more thing to factor the denominator, right?
It'll
You
go
can
through
divide it.
the split.
So yeah, how does this factor?
Yes. It'll become x plus, it'll be x
No,
plus
because
6
it has
and then
a-
x minus 2.
Aha, yes, so x plus 6, x minus 2,
So they cancel.
and then what do you see here?
The x minus 2.
X minus 2's cancel.
So then it's 1 over x plus 6.
What? And then yes, it's 1 over x plus 6 as your final answer. And we know we're done at this point, right? I mean, we know we can't do any more, right? There's nothing left in the numerator to cancel out, and the x plus 6, that doesn't simplify any further.
Could you leave it like, x plus x, like that? Is that only for the top?
So that's only for the top. Because think about it this way, right? If I see this, and I just write this, are they the same thing? Is 1/2 the same thing as 2? Right, but I mean, you can think of it that way, right? And so then 1 over x plus 6, not the same thing as x plus 6. However, if you see this, can I just write this? If I have 2 over 1, can I just write 2? Yeah, same thing. So x plus 6 over 1 is the same thing as x plus 6. Questions on any of that? All right. So then, I'm going to give you guys your assignment.